ladies and gentlemen, and welcome to video 5.2. Today we will be looking at the history of the periodic table and how it came to be and why things may be located where they are. So, starting with the history of the periodic table. The gentleman you see there is Dmitri Mendeleev. And he basically took all of the information we knew about elements at that time, and he started to rearrange them. He looked at their properties, their masses, anything about the atom basically. And he started to group the elements, and he did so according to their chemical and physical properties. So taking ones that were alike and grouping them near each other. Once he was in those set groups, he started to arrange those groups then by their atomic mass. As he did so, he noticed that things started to repeat. Different qualities started to repeat themselves in the different elements within the groups, or maybe across the groups. And this repeating pattern we call periodic. So anything that kind of repeats itself in a nice way we call periodic. That is how then we came to call the periodic table a periodic table. Because it's going to be a table that shows this repeating pattern of certain characteristics of the elements. The cool thing about what Mendeleev did is that as he started putting these elements together, he left spaces in the chart where he predicted there were still undiscovered elements. So in the middle of the chart, you start putting things together and there'd be a hole. So in that hole, he could tell you different properties. He could tell you its mass or what he assumed the mass would be about. He could tell you about what its density should be, how it's going to react, what it's going to be, solid, liquid, or gas, just based on the elements around it. And when those elements were eventually found, he was actually pretty close. With this table, holes and all, it was our first table he published in 1869. Many years later, Henry Moseley came along and he took Mendeleev's table and he, instead of arranging it by mass, he rearranged it by atomic number. Reason this was done is because now we knew more about the atom itself. Back in Mendeleev's time, we only knew that the atoms had mass. But now we know that they were made up of protons, neutrons, and electrons. So we know that if we change the protons, we change the element. Moseley came through, took Mendeleev's chart, and instead of doing it by mass, he rearranged it by atomic number. The funny thing is, in doing this, it basically still followed all of Mendeleev's periodic properties, and most of them stayed in the positions they were. There were just a few that were shuffled around. From here, we can get a periodic law. So what the periodic law says, it has to do with, of course, those properties, is that their physical and chemical properties are periodic functions of their atomic number. So based on their number that they have, the number of electrons, we are going to get certain physical and chemical properties, and we're going to see that pattern repeat. You've kind of already seen that when you were doing electron configurations. You see how we have 1s2, 2s2, 2p6, and then 2s2, 3p6, and you're getting this repeat going on of how electrons are in there. So that was kind of your first introduction into periodic law. So the periodic table, of course, has changed since Mendeleev's time. Few things have been added. Most notable are the noble gases. These were discovered by Sir William Ramsay, and he placed them in group 18. Now, why did it take so long for noble gases to be discovered? Well, what do we know about them? They're basically unreactive. They have full electron configurations. So they have no open spaces. They're not going to react with things. They're not going to want to give up electrons, take in electrons. They're happy. They're full. So they're going to be hard to find. If you don't react with anything, you can't really make them or have them connected to something. So they were the last, basically, to be found of our main periodic table. And we place them in group 18, and you know by electron configuration, it actually is a good place to put them. Other areas added are your lanthanides, which is that first row of your F block, and these would be elements 57 through 71. And these are called our rare earth elements. And then you have the actinides, which is the row right below them. So these are elements 89 through 103. And most of these are synthetically prepared, so they don't occur naturally. We've actually made them, and that's why we know they're there. And of course, hence why they're some of the last elements to be on there. So groups of the periodic table. Remember, groups run up and down. So the first group are your alkali metals. So these are in group 1. These are the red on the periodic table. Second group are your alkaline earth metals. And these are in group 2, so the yellow on the periodic table that you have in front of you. Now remember, everything in a group, it has similar chemical properties. Then we have the transition metals. This is that big green area that we see. So our D block elements are considered our transition metals. So they're getting us from the metals closer into those non-metals. So they're kind of our transition metals. The next big group are your halogens, and these are group 17. So the blue on the periodic table. And the noble gases, which are in group 18, or the purple on the periodic table. Now you can see we have some white. They don't have any specific name. Those are usually, the groups are called or are named based on the element at the top. So you'd have the boron group or the boron family, carbon family, nitrogen family, and oxygen family. And then of course the ones we just talked about on the bottom, your lanthanides and actinides, which are both part of your F block. Then we have hydrogen and helium. Now I kind of referred to them in the last video, or maybe the video before, and said that they're a little bit different. Well, hydrogen really shares no properties with any other group, and it is often separated from the periodic table. Because what do we know about hydrogen? Well, it's a gas. But if it's in group 1, technically it should be considered a metal, and we know it's not a metal. So its position on the periodic table is basically because of its electron configuration. So we know that hydrogen would be 1s1. So everything else that ends s1 is also in group 1. It's just going to be 2s1 or 3s1 as for its highest energy filled orbital. So that's going to be, or they're all going to have the same electron configuration. So that's why hydrogen is kind of put there instead of maybe over on the other end with the nonmetals. Well then, how do we account for helium? Helium is placed on the periodic table due to its chemical properties. Helium has a full electron configuration, so it's 1s2, and we know s can only hold 2. So if it's got a full electron configuration, it's going to act much like a noble gas. So even though it's part of this S block and it has an electron configuration or ends with electron configuration much like everything in group 2, we're going to put it over by the noble gases because its chemical properties are more like the noble gases.